In this section here, we're going to take a look at the third form of the quadratic equation. So we've covered standard form, which is our y equals ax squared plus bx plus c. Doesn't tell us as much in terms of some of the key things we want to know all the time. But the a value is the a value that tells us the direction of opening and the vertical stretch or compression. One thing that you may have recognized, you may not have yet, but if you did recognize it, good for you. The c value is also the y-intercept because x squared and x would both be 0 in that case, and we'd just be left with the c value. So this is the y-intercept. In case of the vertex form, we have our a, again, tells us our direction of opening up or down and our vertical stretch or compression. And then we got the vertex at h and k. And again, remember that negative h there is because the h value flips when you put it into the vertex. So if it's negative 3 here, the vertex would be at positive 3 for the x value. And now our last form here is zeros or roots or factored form. And what that tells us is the zeros of the equation. So the roots, zeros, x-intercepts are at R0 and S0. So we could have a little parabola here, maybe opening up like this. This could be R, this could be S. So we have the 0 points noted from the equation. This is factored form. You've factored before, so you have the ability from the previous unit to transfer from zeros form back to standard form, or from standard form to zeros form. So you're able to get the y-intercept here or the x-intercepts here. In the next unit, we'll take a look at how to translate this standard form into the vertex form. If we continue down the page here, the one thing we're going to look at with this is just mainly how do we find the vertex. So we can find the vertex from the zeros form. Rather simply, quadratics are symmetrical. The parabola itself, is symmetrical, I should say. So if I have a symmetrical parabola here, the vertex is going to be in the exact middle of the two zeros. So the x value of the vertex, or x value here, is right in the middle of the two zeros. How do you find the middle of two numbers? Simply add them and divide by 2. So we take our two zero values, the r and the s, we add them up and we divide by 2. That'll give us the x value of the vertex, and then we can just simply use the equation to find the y value. Let's take a look at an example of that. We have y equals 2 times x minus 4 times x plus 6. So there's our equation. We want to describe that. Then we're going to sketch a graph labeling the vertex and x-intercepts. So quick description here. The graph, so we look at our a value, opens upwards. With a stretch, because it's greater than 1, of 2. And it has zeros at 4 and negative 6. Again, these are in the brackets with the x, so when we talk about them in terms of points on the graph, they flip the signs. So anything in the brackets with the x flips the signs when we pull it out of the brackets in terms of solving. So it has zeros at 4 and 6. So there's a general description of that. Now let's take a look at the next part, which is to sketch that, labeling the vertex and x-intercepts. I'm going to have some trouble figuring out the vertex or labeling the vertex without doing some calculations. So I'm going to actually determine the vertex first. So as in the formula here, or point I'm showing you here, I guess, finding the x value is just simply adding the r and the s, dividing by 2, and then we can find the y value. So let's do that. So the x value is the r, which is 4, plus the s, which is -6, divided by 2. So the x value is going to be 4 plus -6 divided by 2, or 4 minus 6 divided by 2. 4 minus 6 is simply -2. So I have -2 over 2, or that works out to -1. There's my x value, -1. So how do I find the y value? Well, I got an equation here that's got x and y in it. If I replace the x's with -1, that's going to tell me the y value. This is like filling in a mini table of values where I have a table of values with x and y and simply the single x value of 1. What's the y value? So all we're doing here is basically filling in a mini table of values. Y equals the result of 2 times -1 minus 4 times -1 plus 6. I'm not putting a brackets around the -1 here just because it's not needed in this case. There's no multiplication inside here, so this will work out. If it was something like 2x here or a 4x here, something like that, we'd have to multiply with the 1. But this is okay. We're going to stick to this simplistic way of doing it. Anyways, we calculate that out, and we have -1 minus 4, that's going to be -5. So we got 2 times -5 times 1 plus 6. That's going to be +5. And now we have 2 times -5 times +5. 2 times -5 is -10. -10 times 5 is going to give me -50. So there is the y value of the vertex. So the vertex is at -1 and -50. Now I can graph or sketch a little graph of this, labeling the vertex and the x-intercepts. So if I do a quick little sketch here, I'm going to put the x-axis way up high here because we're going down to -50 and these are just 4 and 6. So we have a point here at 4 and then a point at -6, so maybe just a little bit more over, something like that. And then we're looking at an x value of -1 and 50, so down here somewhere. So we have this very narrow graph, and we can label these. There's my vertex at -1 and -50. And then my x values are 0 and 4 and 0 and -6. So there's a labeled little sketch of the graph. So whenever you're working with these, you have your x values, or so your x-intercepts found by just taking the values right out of here. If you need to find the vertex, you take the midpoint or average them out is basically what you're doing here, taking the mean of those two values. Find the x value, and then you can plug that in the formula to find the y value, and then you have the x-intercepts and the vertex. As well, we have our a value here, which still tells us the direction of opening and the horizontal stretch or compression.